In today's lesson, we want to look at the different behaviors of a wave as it either encounters a barrier, a solid barrier, or a different medium, which is also a barrier, a type of barrier. And this is in the second waves booklet. It's called Waves 2D or Waves number 2, and we will look at the first couple of pages in there. So what we've done so far in the first booklet is we've looked at one-dimensional wave behavior. So if a wave directly goes to a barrier, and what does it do then? How does it behave? Or we looked at the relationships of a one-dimensional wave. In this case, the relationships will continue the same way. We will use the same kinds of relationships, so that they stay the same. But to our behaviors, to our properties of wave behavior, we will just add some more understanding, some more properties that apply to 2 dimensions, which means we don't have a direct hit anymore, but we have an angled hit now. So now we have a second dimension in there. That's waves in 2 dimensions. So if you turn to page 1.1, and then we'll get started. And the first thing that I want to point out, or that we want to look at, are these 4 different behaviors that waves have when they hit boundaries. One of them is a reflection, and I think that makes sense. A reflection happens when a wave returns after striking a surface. The best example is probably a mirror, but I'll show you some pictures in a second. Then second, we have a diffraction. Actually, after a reflection, we'll go with a refraction. Now be careful, this is not the same as a rarefaction. When we talked about longitudinal waves, the parts of the waves that were a little bit more spread out, that part of the wave is called a rarefaction, and a lot of people start to get these 2 words confused, so make sure that you don't. Refraction happens when the wave changes a direction between 2 boundaries, or at the boundary between 2 mediums. So as it travels from one medium into another medium, it changes its direction. That is called a refraction. And then we have a diffraction. That happens when a wave spreads around the edge of a solid barrier, or any barrier actually. And then we have interference when 2 or more waves combine, and you have already we've already looked at the interference, but we will look at it again with 2 dimensions. So we have multiple sources at the same time. What happens when those waves interfere with each other, circular waves specifically. Okay, so let's look at the reflection. And to show you the reflection, I will show you this image here. This is from the physicsclassroom.com. A good site for anything concerning waves. So if you have, if you're able to, you should check it out. You can read through it if you want to. But a reflection of a wave is basically as a wave travels towards a barrier and then gets reflected. So here on the bottom we have now on the top of the screen we have the law of reflection, and we'll discuss that in a second. So you have an incident ray going towards a barrier, and then we have a reflected ray coming out of the barrier or from the barrier. That is your reflection. When you have a curved surface, then this is how it looks like. And I'll let you look at it for a second. And then we have, here's another picture where we have the incident ray and we have a reflected ray as it comes back off of a boundary. So if you shine, for example, if you shine a light against a mirror, and you see that it comes back, it bounces back at you, that is called a reflection. Or even if you shine light against water, part of that light gets reflected back to you, comes back towards you, maybe not directly towards you, but at an angle towards you. Now, before we continue about talking about the law of reflection, I want to talk about drawing these waves for a second. So if I go back to the physics classroom here, you can see that there are a few parts that we have as part of drawing the wave, and one of them is the ray, and then we have these lines, and these lines are the wave fronts. You can think about them as crests. So that's how we draw a wave from the top, from the bird's eye view. The ray tells us the direction of the wave in which the wave is traveling, and the lines tell us the crests or the crests or the troughs. It doesn't matter as long as they are the same of the wave. So that means from a line to another line we have a wavelength. So that's the first thing that we want to put down into our notes here. Just how do we draw these waves? Just so we're on the same page together. So the direction of a wave is drawn with a wavefront being the leading edge of the wave, and it is either a crest or a trough, as I mentioned before, and it looks kind of like this. So here are the wave fronts. And so in this case, we have a wave that is either traveling to the right or to the left. We don't know what it would be, and so we need to identify what that is using a ray. And so this would be our wave ray, and these would be the crests or the wave fronts, we say. So this is the wave ray, and these are the wave fronts. So the wave array kind of shows us the direction that the wave is traveling into or to. The direction of travel of a wave is shown by the wave ray, and it is drawn perpendicular to the wave fronts. Okay. Now you can do this with straight waves. So we have a solid piece of wood, for example, and we generate some waves in water. This is one of them. Or when you take your finger and you just dip it into water, you're creating circular waves. So they kind of look like this. This would be one wave front. Here's another wave front. And starting from the center, these wave fronts would be traveling away from the center, and so we have these wave rays pointing away from the center, and this kind of shows you your ripple effect coming from a center in water. Okay, so here we have the wave ray, and here we would have the wave fronts. So that's how we kind of draw waves. One thing to mention, as I did before, just to put that in here, from here to here, or from this point to this point, this would be a wave length. Okay, from one wavefront to the next wavefront is from a crest to another crest, or from a trough to another trough, which means that we would have a wave front. Okay, or sorry, a wavelength. The law of reflection. The law of reflection states that the angle of incidence, and so this is actually, before I go into that, let me go back to the pictures here. We have an incident ray, what we call an incident ray, and the incident ray is the ray that approaches a barrier, and then we have a reflected ray, and the reflected ray is the ray that comes off of the barrier. We also could use a refracted ray, and we will get into that in a second. But for now, we have an incident ray and a reflected ray. So when you look at this image here, the incident ray is the ray that approaches the barrier, so which is in this case a reflective surface, and then you have a reflected ray on the bottom, and that ray is coming off of the barrier, and then we have an angle, or two angles actually. We have an angle of incidence, and that is the angle between the normal of the barrier and the incident ray. And then we have the angle of reflection, which is the angle between the normal of the barrier and the reflected array. Okay, so a couple of terms that we will get used to, and we want to draw this image, and we'll just include those terms in that image so we can understand what we're, we can learn these new terms. So as you saw in that image, the law of reflection says that the angle of incidence is actually the same as the angle of reflection. And this is very easy to show. If you take a mirror and you put a protractor in front of the mirror, and then you shine a narrow light. So if you have a flashlight, for example, and you use a slit take a piece of paper, a dark piece of thick piece of paper, make a slit into it, like about a 2 millimeters of a slit, and you shine your flashlight through that slit and towards the mirror, and you measure the angle that your light hits the mirror at, and you measure the angle of reflection afterwards. You see that the angle of incidence and the angle of reflection are the same. Now, when reflection occurs, that means the light goes into one. Let me draw it instead, and then I can use that as the example. So here we have our barrier, and this just simply means the light can't get through. And then we have the normal to our barrier, and I will just use a green pen for it. And here's where I noticed that I'm missing a protractor right now. So I'll be back in a second. And I won't be able to find one right now, so I will make sure that I have it ready for the next video. So I will use a straight edge here, and the normal of a barrier is perpendicular to the barrier. So it looks kind of like this. This is called the normal of the barrier, and this angle is perpendicular. Okay? So now what happens is, let's say I have a wave that is traveling towards the normal. So now I would have a wave ray that is perpendicular to my waves, my wave fronts, and hitting my normal. So something like that. Here are my wave fronts. This is the wave ray hitting the barrier, and then I have the normal at this point where the wave hits the barrier, and this angle here we call theta 1 or theta I for incident, and then we have the wave is being reflected back again into, or back again, for now I'll just say that, and this angle here is called theta 2, or a reflected angle. Okay, and then we would have the wave fronts on this wave as well. Now here's the important thing. When I hit a boundary, let's say this is a mirror, your light goes through air, hits the mirror, and comes back into air again. Your light or your wave does not actually change a medium. And so if it doesn't change a medium, that means that from our last section, you should know that if it doesn't change a medium, your wave stays the same. It doesn't change. So the wave lengths will stay the same. So which means our wave fronts will have to have the same distance from each other. The speed stays the same, and the wavelength stay the same. So when reflection occurs, the speed and the wavelength stay the same. And on top of that, these two angles are equal to each other as well. So we can call it that, we can say this mathematically or algebraically, we can write it down like this. Theta 1 is equal to theta 2. And V1, so the speed before the reflection, is the same as the speed after the reflection. And we can also say that lambda 1, so the wavelength before the reflection, is the same as the wavelength after the reflection. So this is our incident ray, and this is our reflected ray. This is our incident angle, this is our reflected angle. Let's put those terms in here as well. So theta 1 means the incident angle, V1 means the incident speed, and lambda 1 means the incident wavelength. And the same thing happens with the other one. 2 just stands for the reflected one. So this is the law of reflection, okay? Basically saying that your angle is going to be the same when it reflects as it is when it hits. And the angle should always be measured between the normal of the normal of the boundary, and the ray, the incident ray or the reflected ray. And I'll just label this as the boundary here. And at this point, we're just going to work with a solid boundary, because all we want to talk about is the reflection right now. Okay, so that is the reflection. Okay, that's the first one. Now we want to go into refraction. Let's look at refraction. And I will just quickly talk about what a refraction is, and then we will look more into a refraction later on in this booklet. So this is a refraction. A refraction happens when your wave bends in another medium. So if you look at this light, it shines towards the rectangular prism here, and it bends, it changes its direction. And the reason why it's changing its direction is because the medium, the plastic medium, is denser than the air that the light came from. So if you take this as an example, if you look at water, and let me just show you a picture instead. If you look at water from the side and you have a straw in it, you can see that your straw looks kind of bent. Or if you take a coin and you place it into the water, you can see that from one angle, from right on top of the water, it looks closer to you than it does when it's when you look from the side at the coin. That is the reason, or that's the result of a refraction. So this is what a refraction is. The light gets bent when it goes from one medium into another medium, or a wave gets bent when it goes from one medium into another medium. That is called a refraction, and we'll look at that a little more close later on in this unit. Okay? And then the third thing was diffraction. So we've talked about reflection, we discussed that in detail. A refraction we'll discuss in detail later on. And then we have diffraction, and this is an example of diffraction. If you actually, let me go to this page here, and I'll go to diffraction here, the image for the diffraction. The diffraction is the bending of waves around a barrier, around a solid barrier. So in this case, for this part, all you need to know is that when diffraction, or when a wave hits a barrier, it kind of bends around that barrier. That's all we will talk about for diffraction. So if you look at this image here, if you look at the diagrams on the right-hand side, you can see a solid wave traveling, or a straight wave traveling towards a slit between two barriers. And you can see how the waves bend around those two barriers. In the second image, you can see a wave bending around one corner of the barrier. And then in the third image, you see a wave bending around two corners of one barrier. And the same thing happens if you had a circular barrier. Now, if you look at the actual image, the real wave image, you can see that diffraction, that bending of the water waves. That is not the only thing that you can see. I think you should also be able to see, and I can't point that out here, you can also see the interference between the waves. So what do I mean? If you take, for example, if you look at the middle of this picture, of this image, and you can see how the waves bend around the two barriers on each side. Now, if you look at the left side of that image, you can see that there's another gap, and the waves that bend on the left side towards the right, those waves interfere with the ones that have been generated from the diffraction of the middle gap. So the diffraction, the diffracted waves that have been generated from the left gap interfere with the diffracted waves that have been generated by the middle gap. Let me show you another interference. Here's another interference between two different waves. One of them comes from the top left, and the other waves comes from the from the bottom left. And as they meet each other in the middle, to the right a little bit, that's where you can see an interference pattern between those two waves. What we will go into, what we will look into in the next lesson is the image that you, or the simulation that you see here on the right hand side. That is an interference between 2 point sources. So if you dip your fingers into the water, if you dip two of your fingers into the water at two different spots, you will get an interference pattern between those two waves. So that's what we will look into in our next lesson. So if I come back again to our notes, what we've talked about right now was a reflection, which is the important thing about it is that it comes back at the same angle with the same speed and the same wavelength. Okay, that's a reflection, happens when you hit a boundary and the wave comes back from it. Refraction is when your wave, instead of coming back, while it does still come back, there's part of the wave that comes back. It goes into the next medium and it bends. That's a refraction, and we'll look at that more closely next time, or later on. Then we have diffraction, and diffraction is the bending around a barrier. Okay? And then we have interference, and interference happens when two or more waves start to combine with each other, interfere with each other, and we will look at that in our next lesson. For now, what we want to do is we'll go to the next page, and I just want you guys to get used to how reflection works, or how a wave gets reflected and diffracted. Okay, so here we have diffraction, and here we have, up until this point we have reflection, and from here we have diffraction. And I'll just walk you through that as we in the next video together.